Hello there. Welcome to this lecture. The lecture forms Chapter 9 of the IT Essentials course. The Cisco IT Essentials, Chapter 9. We are dealing with the Chapter 9 with the title Virtualization and Cloud Computing. That is what we are learning in this chapter today. We want to learn about virtualization, how a virtual machine can be installed on a computer. We want to explain server virtualization. We want to learn about virtualization software on a computer. Also, we are dealing with cloud computing. We want to compare cloud computing concepts. We want to describe the uses of the cloud and then the characteristics of public, private, hybrid, and community cloud computing. Those are some of the things we are learning in the lecture today. So please follow along. Make sure you watch to the end so as to understand fully the concepts of virtualization and cloud computing and see how the two of them are related and work hand in hand. Thank you very much for watching the video. Now, when we talk about virtualization, it's a concept that I can explain with somebody that was transferred with his family to another city. And upon getting to that city, he needed to rent an apartment. The landlord was there, but he needed to rent the apartment that the landlord was not using. So he was a guest in that compound, but he has every right to the apartment because he has been paying rent to the landlord. So that is what I can use to describe the concept of virtualization. Virtualization is a system, is a technique by which the computer system is installed on another person's computer. The hardware of the owner will serve for both purposes. The hardware will serve as the host, and also it will also receive guests. The guest is receiving that guest in form of a software. That guest doesn't have hardware of its own. Like the man that was transferred to another city doesn't have a house of his own in the new city, but rather he has to pay the landlord to stay in an apartment and be comfortable there. Likewise, the guest machine on a host machine is residing, the software is residing on the host machine. And so you can be able to use all the hardware, the hard drive, the CPU, and every other thing that is present on the host machine. Now, before we continue, I want to remind you to subscribe to this channel. Do subscribe to the channel, like this video, and share it as well. If you haven't subscribed, subscribe to the channel so that next time when we are bringing new videos, interesting and educational videos like this, you will be notified by YouTube. So thank you as you do so. So let's continue on the explanation of virtualization and the cloud computing. Virtualization and cloud computing work hand in hand. They work hand in hand. And of course, almost everybody has been using cloud computing from the day one that you open an email, or since the time you have been using social media, such as chat, messaging, using drives, Google Drive, for instance, or Apple Cloud, and so on and so forth. We've been using cloud computing without knowing it. But right now, we want to show the relationship between these two concepts today, and the benefits, the advantages of using virtualization and cloud computing. So we want to look at the definition of a virtualization. Virtualization is a system by which a single computer is used to host multiple independent computers that are called virtual machines. They are called virtual machines because they don't have the hardware of their own. Rather, they are installed on only one hardware. And then the hardware on which they are installed is referred to as the host. Whereas the machines that are installed on that hardware that are not having their own hardware are referred to as guests, or they are referred to as virtual machines. So virtualization software separates the actual physical hardware from the virtual machine instances. The virtual machine don't have hardware, so they are separated from their own hardware. They are using the hardware of the host. And in this process also, an image of the virtual machine can be saved on a file and restarted when it is needed. So it doesn't have to always run on the host. Now, let's look at the cloud computing. Cloud computing separates applications from hardware. Yes, you want to use hardware somewhere, but the hardware is not residing in your location. You are using hardware that is far away in the cloud, in some powerful servers. So there, you begin to communicate and operate remotely. So it means the cloud computing process has separated the application that you are using from the hardware on which you are using it. And this service of a cloud computing system is provided by big organizations such as the Amazon Web Services, AWS. They own and manage large cloud infrastructure. So they are the one that provide facilities, software, hardware, support, and so on for other organizations to use their cloud. Now, let's look at the traditional server deployment. Organizations that run their own private servers, they will need to run it, service it themselves, and then they must use powerful dedicated servers. These dedicated servers are equipped with large amounts of RAM, powerful processors, very powerful CPUs, and multiple large storage devices. Yes. Now, when they operate in this manner, the disadvantage is that they are wasting resources because there is a single point of failure. So if there is going to be any problem, and then the servers is going to be attacked, the attack will just affect them, and it will be hard or difficult for them, to come on instantly, like it will be for a cloud computing system. Apart from that, there will be server sprawl. Their server will be dragging. It will not be able to operate efficiently because it's just a single point system. So as we have in this graphic that we have here, each company, we have dedicated servers for web server, operating Windows OS, email server, operating Windows OS, SQL server, operating Windows OS, file server, operating in Windows OS. All these are, housed in the same dedicated server, having hardware such as CPU, memory, a network interface, card, disk, and so on. All of them are privately set up by one organization. So this has a lot of disadvantages. Now, the benefits of cloud computing now make organizations to subscribe to bigger organizations such as the AWS, Amazon Web Services, to use their cloud. All right. Now, let's see. Server virtualization. Now, when you now operate virtualization, what happens is that there will be so many advantages. The idle resources will be used efficiently or judiciously because the number of servers required by different organizations will be reduced. And then to actually achieve this, a special software is applied called Hypervisor. You can imagine Hypervisor as a software that supervises a supervisor or supervising software that is used to manage resources on the host to take, hosts, on the host system to take on guest system, the virtual machines. Then this software provides access to the hardware of the physical machine on the host to the, guest systems that are coming in as only software. So the hardware such as CPU, memory, disk, controllers, network interface cards, and the rest, they are being used by the virtual machines, and it's a hypervisor that gives them access to these hardware, services. Each virtual machine runs a complete, separate and operating system. They have their own complete separate operating system installed on the hardware of the host computer. Now, if you look at the graphic we have here, this is a block diagram description of what is taking place. The hardware down here is hardware of the host computer. And then on it, the hypervisor is interacting with it and giving access to the Windows operating system, Linux operating system, different operating system of the virtual machines, which have different software applications such as DHP server, AD server, radio server, NMI server, or what have you, depending on the operating system that is being operated. So hypervisor makes access possible for these virtual machines to utilize the hardware of the host. All right, now what are the advantages of server virtualization? When you have this system in place, there are so many advantages that are attached. For instance, there is a better use of resources. Each organization that run their private servers will spend a lot of money to make sure that they are up and running 24/7. But when they subscribe to bigger organizations such as the AWS, they pay particular amounts, and then that amount will not be, up to when they run their private servers. When they, launch their own traditional server, it won't be like that. The money will be reduced. Apart from that, less space is required. The companies will require less space because they will only need other small computers to communicate through the cloud to the main server where it is located. They will not need to, house many servers at their location because all these servers are being hosted virtually through virtualization somewhere. Then apart from that, there will be less energy consumed. Electrical energy will be less because they are not hosting so many servers privately. It is only a few small systems that will be running on using electricity because the servers are installed far away remotely on a virtual machine, on a host machine virtually. So there will be less energy consumed because they don't run their private servers. Those servers will, ordinarily, if they should be installed, will be running on electricity 24/7, whether they are used or not being used. And more often than not, these servers will not be used 24/7. They will have a lot of idle times, but they must be connected to electricity. They will be using power. So energy will be wasted in that manner. Apart from this, there will be reduced costs. Cost of setting up an organization system of server and networking will be reduced if they subscribe to virtualization and cloud computing. Because they are not running their private system, cost of electricity, cost of infrastructure, facilities such as building, personnel that monitor server and keep them running, all these costs will be reduced. More than that, there will be faster server provisioning. If you operate virtualization, the organizations that run the servers, the powerful servers, they keep them running 24/7, 365 days a year. And so they have certain operations put in place such that they will minimize failure. And so if there's any lack, they will quickly restore any issue because they have the capacity to do so. So there will be faster server positioning through them. Then you will also maximize server uptime. If you run your private server for your organization, for instance, those servers will have idle time, they are not working. So the uptime will be small, and then the idle time will be there. But for bigger organizations, such as AWS, they ensure that the servers are being used judiciously in terms of uptime, so they can maximize server uptime. Then there is improved server recovery. There is improved disaster recovery. When there is a problem to the network or to the servers, if you are using a virtualization, there is opportunity when there's an attack or a problem for the system to come up as fast as possible, because such organizations, they have what we can call a redundant system, redundant servers that are actually monitoring what is happening on the network and saving information as backup. So when there's any problem on their main servers, they have the capability of starting up almost immediately with the backup system, the backup servers. So there will be improved disaster recovery. Then there is support for legacy systems. Support for legacy systems. That's another advantage with virtualization. This may not be easy or quite practical for private server installation, but with a major server installation with a cloud computing and virtualization, it is possible, to have support for a wide range of systems. Okay. Now, let's look at the next. We've discussed the advantages. Now we want to look at the client-side virtualization. We've been discussing server virtualization, which actually the high-end computers. It deals with the high-end computers. What about client-side computer? For instance, a personal computer like this, like the one I'm using right here, how can we actually carry out a virtualization? So that is a client-side virtualization. Client-side virtualization is also possible. There will be a host, the host computer that will run the host operating system on the host hardware. Then there will be virtualization software installed. That is a hypervisor. In this case, we have a type 2 hypervisor. That hypervisor, for instance, we have examples such as Hyper-V, Virtual PC, VirtualBox. These are examples of a client-side virtualization software, hypervisor type 2. So this will ensure that the guest computers are installed on the hardware of the host. So the guest operating system will be installed, and then applications of the guest operating system will also be installed on the guest operating system. So when we have this system, then it makes other users to run their virtual machines on one local computer. And then other virtual machines that are run on the local computer will be, used. They will be using the hardware of the host, while the owners will be using them remotely. They'll be communicating with their system, with their virtual machine remotely using cloud computing. Then this allows users to test new operating system software or to run older software. It's a way by which software can be tested by carrying out a virtualization, the client-side virtualization. The host system is a computer that is running the hardware physically, that is taking, other computers, virtual machines as guests and installing them. The host operating system, the operating system of the host computer, while the guest operating system is the operating system of the virtual machines. So earlier I mentioned type 1 and type 2 hypervisors. Type 1 hypervisor is the hypervisor used for, server virtualization. That is for high-end systems. And we have, for instance, in data centers and cloud computing, they use type 1 hypervisor. And we have, excuse me, we have examples of this hypervisor as VMware, vSphere, ESXi, XEA, Oracle VM Server. These are examples of software that are used as type 1 hypervisor. This is the software that is installed on the host operating system to take in control of virtual machines that will be coming in. That is the guest computers. So that is type 1 hypervisor. You can see a block diagram here that explains how this works. The hardware is first, yeah, after the hardware that is running the main operating system, the host operating system, then we have a hypervisor installed that controls the OS of other virtual machines. That is a type 1 hypervisor. We have the example, VMware vSphere hypervisor. And so on it, we can run Windows Server. On it, we can run Windows Server, we can run Linux Server, or that type of operating systems. All right. Now, apart from that, we want to also talk about a type 2 hypervisor. Type 2 hypervisor is the hosted, is for client-side virtualization. Client-side virtualization, whereby we are talking about systems that are not working as servers. That could be local systems. And the type 2 hypervisors is the one that is used on the host system to create multiple virtual machines. And we have an example of such hypervisor, the type 2 hypervisor, as VMware Workstation, Windows Hyper-V, and Oracle VirtualBox. These are examples of type 2 hypervisor. All right. Now, when a system is going to be used as a client-side virtualization, what is the requirement? So these are the virtual machine requirements. For Windows 10 operating system should be Windows 10 Pro or Windows 10 Server 2012 and 2016. That is if it is a local personal system or a server. Either of the two can work, Windows 10 or Windows Server. So Windows 10 for Windows 10 Pro for personal system, processor should be 64-bit CPU with second level address translation slots. The BIOS must have CPU support for virtual machine monitor, mode or extension, VTC or Intel CPU. Intel CPUs are capable of doing this. Memory, the memory should be minimum of 4 gig. Yes, the RAM should be minimum of 4 gigabytes. And then the hard drive space must be at least 15 gigabytes for each virtual machine. So if you are bringing in, for instance, 4 virtual machines, 60 gig of the hard drive, at least 60 gig of the hard drive must be reserved for that. So in Windows 10 Pro, the Hyper-V is already included in that operating system. Hyper-V, that is the type 2 hypervisor is included in Windows 10 Pro. Now the next one, virtual machine requirements for Windows 8, almost the same thing. The difference is that the operating system, the host operating system should be Windows 8 Pro or Enterprise 64-bit operating system. And then the processor, the same, like Windows 10, 64-bit CPU with second level address translation slots. The BIOS must be a BIOS level hardware virtualization support. It must have BIOS level virtualization support. The memory, minimum of 4 gigabytes system RAM is needed. Then hard disk space, 15 gigabytes for each virtual machine. If you are running 3 virtual machines at least, you need 45 gigabyte space reserved for that purpose. Also, virtual machine requirements for Windows 7, the processor should be 1 gigahertz, 32-bit or 64-bit operating system. 64-bit processor, 1 gigahertz, 32-bit or 64-bit processor, that is the CPU. Then the memory at least requires 2 gigabytes memory. And the hard disk space should be at least 50 gigabytes for each virtual machine that is going to be installed. So the same thing, that's condition is for the 3 operating systems. Now, we move on to cloud computing. Now, how do we use cloud? All of us have been using cloud since the time we opened our email. It's the time we've been using a social network, storing our files from our devices, such as our phone, pictures, files, videos in cloud. We've been using cloud computing. Once we are doing all this stuff on the internet, we've been using cloud computing. Now, what we want to bear in mind is that cloud computing services are owned and hosted by service providers. And then we use all these services almost free of charge. Use social media almost at no cost to yourself. And then you access online music library, online storage, you save photographs. All these services that we use, organizations pay for the facilities that make all this possible for us. And the But for the users, it's almost free of charge, or free of charge as the case may be. But the cloud that we use is operated by organizations. They are large computer that has high capacity to store information and to send and receive information. Then cloud computing services. We have 3 types of cloud computing services. And these are the various services that service providers can provide to meet requirements of a particular client or customer. For instance, the first one is SaaS, software as a service. In this system, the software applications such as email, Office 365 are provided over the network on a subscription basis. So the organizations that subscribe to the cloud computing service, they will pay for that service. And this is typically used by end users. It's typically used by end users. Then we also have second one, PaaS, platform as a service. Here, tools and services used to deliver the applications are provided for the customer, which includes operating system and application stack. So they use their platform for all this. And this is typically requested by application and software developers. So they can use it to do their stuff, to develop their program, to test run, and so on. The last one is infrastructure as a service, IaaS. This includes network computers, virtual dedicated computers, and storage that are being provided by the cloud computing organization. And this is typically used by organization infrastructure and network architects. So also, cloud service providers also have an extended model of the IaaS, that is infrastructure as a service, to provide and also provide IT as a service, ITaaS, that is information technology as a service. They also provide that. Now, cloud computing characteristics. We have these 5 characteristics of the cloud computing. One, on demand, that is self-service. Second one is rapid elasticity. And the next one is resource pooling. The next one is measured and metered service. Then the last one is broad access network. Cloud computing services are able to provide various types of these, computing characteristics. So that is virtualization and cloud computing. What have we discussed so far? We have discussed virtualization and cloud computing and how they work hand in hand. Now, I want to explain here that virtualization is a beautiful technique in computing. Meanwhile, virtualization may be impossible or not useful to computer network computing and organizations if there is no opportunity to communicate virtually to the virtual host machines by virtual machines. The owners of the virtual machine, if the owner cannot communicate virtually, cannot operate virtually, is a virtual machine in the host system, then virtualization is not useful. For that reason, we want to say that virtualization is made possible by cloud computing. Without cloud computing, virtualization is useless. There won't be opportunity to use the hardware of the host remotely if there is no cloud computing. So cloud computing, that is using, several powerful computers far away, servers, via the internet. That is a little definition I want to give to cloud computing. Storing, receiving, transmitting to the cloud. If there is no internet facilities that made this possible, then virtualization will not be practical. It's impracticable to actually dabble into virtualization without cloud computing. So in this chapter 9, we have explained virtualization, we've explained server virtualization, we explained client-side virtualization. And we have also described the uses of the cloud, like I've explained. And we have looked at how to install virtualization software on a computer. We talked about hypervisor, type 1 hypervisor and type 2 hypervisor. The type 1 hypervisor is for server virtualization, while type 2 hypervisor is for client-side virtualization. We look at the characteristics of a public, private, hybrid, and community cloud computing. We have talked about how they operate, the advantages, the characteristics, their property. So this is the summary of the chapter. Thank you very much for watching. And then if you have not done so, please subscribe to the channel. I want to also request that you like and share this video. like and share this video, subscribe the channel. So until another time when we meet, I want to say bye-bye. See you next time.